Okay, so this lesson is to solve, and I should probably put here quadratics. So solve quadratics by completing the square. Now you'll notice the last lesson was also solving quadratics. So when do you use this completing the square method? Is when a equals 1 and b is even. And we're talking about the a when we have a quadratic in standard form, the b and the c. So when a is 1 and b is even, then you could use completing the square easily. And of course, it's my recommendation to only use it when it's easy. So before we actually start completing the square, I want to give you this problem. And I want to talk about how we could use our new knowledge and we could multiply this out and we could get a quadratic and we could move everything to one side and we could use the quadratic formula to solve. But that would be pretty complicated. In reality, this is just something squared. So I can solve this like a regular equation by square rooting both sides. Now, something important for you to understand is whenever you square root both sides of an equation, you always need to have plus or minus. So what happens is the squared and square root cancel, and you're just left with x plus 6. But on this side, you're going to get plus or minus, and the reality is square root 12 can be simplified. So that's actually going to be 2 square root 3. And if you're wondering what did I do to get that, remember I tend to use the cake method. So if I do this, I have a pair of 2s, so the 2 goes out in front, the 3 goes inside. So this plus or minus, I'm suggesting that you should write a sentence in your notes right now that says, whenever you square root both sides of an equation, make sure to put plus or minus, okay? And the reason that we do that is because if I have something squared equals 4, well, think about it. 2 squared equals 4, but negative 2 squared also equals 4. So when I go to square root, I can't automatically say that it was 2. I have to say that it was positive or negative 2. So this is sort of the reason behind it, but you should highlight that. All right, so from there, I just need to get x by itself. So I'm going to do regular algebra and just subtract 6 from both sides. Now, here's where the interesting point comes in. These are not like terms. This one has a square root, this one does not. So what you're going to do is you're just going to write them separately, and the final answer looks like this. And you might think, well, that looks a little like when I do quadratic formula, and you would be correct. So basically, this is getting you the same kind of answers that you would when you do quadratic formula. All right, so with all that being said, let me show you how to actually complete the square if it's not already given to you as a perfect square. So here are some examples. And we're going to go with number 1, x squared plus 16x plus 29 equals negative 10. Oh my goodness, you can't even see what I'm writing. Here we go. Sorry, write that down. Okay. So first of all, does it meet the criteria of when I should use completing the square? The a is the 1, the b is even, so I'm okay. So what we're going to do is we're actually going to move this c over to the other side. So this is different than the other methods I've used. I don't want it to equal 0. As a matter of fact, I just want this c spot to be blank. So I'm going to minus 29 from both sides. And I get x squared plus 16x. And I'm going to leave a blank here because I know what's coming. Equals negative 39. All right, now this is not a perfect square yet, but in order to make it a perfect square, I can take the b, so this 16, and I'm going to do 2 things to it, okay? take b, and I'm going to divide by 2, and then I'm going to square it. So if I take 16 divided by 2, it'll be 8, and if I square that, it'll be 64. So what I'm going to do is I'm going to add 64 to both sides. So once you do that, this process, you're going to add it to both sides. Okay, now you might be thinking, okay, what does that do for us? I feel like the problem just got more complicated, but it didn't. This thing right here, okay, is a perfect square. So it is actually the same as x plus 8 squared. And how do I know that? Basically, I know that because whatever this number is divided by 2 will go here, and it's squared. Now, how do I really know that? It's a pattern, and it's something that I've taken time to learn. You can take time to learn it as well. Basically, you have a pattern that I showed you back on the factoring, where you take this number times 2, and then this one squared, and it is how you get the perfect square. All right, so for the other side, okay, that was a lot of talking for a pretty basic idea, that if you just want to write it using the number you got when you divide by 2, that's fine. Okay, it's a perfect square. All right, so then from there, I'm using a calculator to double check and make sure I don't get this wrong. Negative 39 plus 64 is 25. All right, so from there, I'm going to square root both sides, just like I did up in the example above. So I'm going to get x plus 8 because my squared and square root cancel each other out. On the other side, I need to put plus or minus. And really, what's the square root of 25? Don't leave it square root of 25. You should know that that equals 5. So I have plus or minus 5. To finish solving, minus 8, minus 8. So I've got x equals negative 8 plus or minus 5. Don't leave your answer like that. A minute ago, we left our answer like that because we couldn't simplify. This time we can simplify. These are just two different problems. Negative 8 plus 5 and negative 8 minus 5. And those both have valid answers that you should be able to tell me, okay? So negative 8 plus 5, that's going to be negative 3. Negative 8 minus 5 is negative 13. So our two answers, remember quadratics often have two answers, are negative 13, if you want to write them in order, and negative 3. Okay? All right, let's do one more example. I think I can fit it into the time. So number 2, I just have to get back to my examples. Number 2, let's try this one. X squared plus 8x minus 73 equals 9. All right, so here we go. First things first, move this over. Move a blank spot. This is going to be 82. All right, so I take this number, I divide it by 2, and then I square it. So divide by 2, you get 4. Square it, you get 16. You better add 16 to both sides. So then this is, remember, your number when you divide it by 2. So I got positive 4 when I divided by 2. So this thing squared equals, this is going to be 98. Square root both sides. So I get x plus 4. This side, I'm going to do cake method on the 98 just to check what it should be. So I'm going to get 49, which is a perfect square, so good thing I tried. So 7 goes on the outside, but remember I'm putting plus or minus, otherwise I'm going to lose points. 7 square root 2. Alright, so move the 4 over to the other side. x equals -4 plus or minus 7 square root 2. And we can leave our answer like this because it has a square root in it, so that part can't be simplified any further.